Hello, welcome to the TLS working group meeting at IETF 123. Everybody please find your seats and enjoy the ride. Okay. At this point of the week, it's pretty early. You may not be familiar with the Note Well, but it's a good idea to become familiar with the Note Well. It discusses various processes we have in the IETF that cover such things as intellectual property, copyright. It also covers how we should treat each other in our meetings and our discussions. Remind everybody to keep things professional so that we have a productive meeting. Some tips, probably the most important thing for people here is that in the room, you should join the meeting with the on-site tool. So not only can you join the queue to participate in the discussion, but we will also get a proper counting of the number of people who attend the meeting so we get the correct size room. Okay. This is our agenda for today. I will note we have a note taker already, but please feel free to help out, as sometimes maybe our note taker may be talking at the mic or have other things that they need to attend to. So if people can check and make sure that things get recorded correctly, that would be fantastic. So today we have some status updates for the working group items. Discussion of the catch draft from Stephen, key update from Yaroslav, jumbo records from John, ML Chem from Deirdre, and then a discussion of some PAIC items from for the working for that are non-working group items, and also dual certs from Yaroslav. Is there any other agenda bashing that we want to do here for Tuesday? I'll just note on Wednesday we have a bunch of non-working group items lined up as well. If nobody has any amendments, we will move on. Is that it? Yeah. All right. On to working group status. All right, where did they move the shared slides button to? How'd you get the first one up there? That's what I was trying to figure out. I thought I just did this.
Oh, here we go.
Oh, yeah, you're here.
Yeah.
You got it?
Clicker's got it. Take control from the clicker. Yes. Then I can make the change. All right. Confirm my selection. All right, cool. Now I'm going to know. It's like, does this still work? All right. Sorry about all that. I had to remember what slides to click or what buttons to click and in what order. Hey, I just want to give you guys a status update. I know this is probably a little longer than normal, but we got a lot of things in flight, and I just want to make sure everybody's aware of actually what's going on. All right, so we have 20 active working group IDs. I'm not going to list them, but I'm going to show you that some of them are actually quite close to being done. So we have more than 5 expired drafts, but these are the most recently expired drafts. And I'm pretty sure that all the authors would say it wouldn't be expired if I just had more time. So, I'd get it done. So unless any that are listed up here, and that's not true, like you want to abandon them or, you've given up or something like that, let me know. But I have a funny feeling that some of these can come back after people get some freed up time. One of the more exciting things, we've actually got a bunch of documents recently that we've gotten through the process, and they're actually with the RFC editor's queue. The one that just, finally, but RRC took a long time, but it's through 8447 BIS, the bootstrapping stuff. The stuff for ECH, I think, is at the point now where the RFC editor and others are asking specific questions about the draft, so they're moving along quite nicely. We have 2 that are approved by the ISG. They're going to go into the RFC editor's queue very shortly after some minor tweaks. Ecker posted a new version of TLS 1.3. There's 1 PR that is open, and we're going to leave it open like till the end of the week, basically. So you should get into the GitHub repo and see if you agree with the wording changes there, or if we're just not going to adopt it. The other one, the deprecating obsolete key exchange mechanisms, picked up 2 discusses from the ISG, and those are like blocking comments that you can't go forward unless you address them. They're not technical. It's more kind of like, how can you read it and misunderstand it and trying to make it clear. So Joe's working with Nimrod to get those addressed, and we'll end up moving that one forward. And, when he's got time, we'll get through those. And so I'm hoping, that's weeks away. All right, we got another one through the IETF last call, the hybrid key exchange document, the design principles. So that's with Paul. So when he gets time, when he gets home, he'll go through and read it to make sure that everything's done and good to go, and then he can put it on the ISD telechat, and we'll see what comments we get there. We got one in IETF last call. I believe it ends on the 28th for the extensions for using certificates with the external pre-shared keys. Again, thanks to Russ for all of his patience as we work through the FAT process. We have 2 that are ready right now to go to working group last call, and we're going to start them probably on the end of the week. Mostly because Stephen actually hasn't asked for it explicitly, I think, for the working group last call for the second one, which I think he will in about 5 minutes. And the first one, we literally just sent out an email today that basically said, hey, this is just adding a cipher suite. It doesn't need to go to the FAT. So let's just get on with it and actually do the working group last call. All right, FAT review. So this is with 2 that we decided that didn't actually need to be, that didn't need to go to the process. So I think Deirdre put in some changes to the FAT fact that we have about saying why we did that, and there were some messages that we sent to the mailing list, so if anybody objects, they can. In process, we have the extended key update has been sent. I saw that Ecker, I think, and Dennis also sent comments as well, so we appreciate that. Again, we're going to need to identify a point person who's going to do that and can take the whole process. And then again, the next one is this TLS 1.3, which is going to need some review, and we'll have to find somebody. I'll probably actively be reaching out to somebody on the FAT to be like, hey, would it be really cool if you could volunteer for this? What's next? All right, working group adoption calls. This is why I thought it might take 20 minutes. The next 3 slides, everyone take a breath. Right? So SLHDSA, we're redoing the adoption call. We were appealed. We decided that we were in the wrong, and so we wanted to do it again. And so that working group adoption is going on now, right? We then have another 3 others that we kind of lined up that were kind of in the queue. The one of use of composite MLDSA and TLS 1.3 was the next of the PQ things, but now we have this dual certs thing, and so we have to figure out whether the working group is going to do one or both or what. So we're going to kind of see if we can wait. So that's going to be my proposal. So we're going to basically try to like put that on pause for a second and go. Now we think that's okay because again, the working group was very adamant about like address harvest now, decrypt later, and so we think that that's probably okay. And at the end of the day, we also don't think that that conversation is going to go quickly. It's going to take a while before we settle on how to do them or pick one and the whole 9 yards. So we're going to be moving to do an adoption call for the PAIC. So if Laura's got a slide and then she says, please do an adoption call, we're going to do it. And again, we already had a discussion last time and we had like a session, we took a sense of the room and it was like pretty overwhelmingly that people were interested in working on the PIC stuff. And then we had MTLS flags. was on there where Jonathan said, hey, I've got this draft, and there weren't a lot of other people that thought they were going to implement, but then somebody from Chrome was like, we do want to do it. But then Yaroslav recently was like, well, we have this other way we might do it. So I'm going to pause that one as well. All right, then we got all these PQ algorithms. Again, this is kind of a rehash of what's going on. Like, I don't know how many messages you see on the list. I get 3 times as many off list about this stuff. So we've adopted, the hybrid one. We got the pure ML-Chem one. It was appealed. I think that was the one that went to the IAB. I don't know. It's been appealed multiple times, but it's been revised again. Deirdre's going to get a couple talks about it in a couple minutes. And then we have MLDSA as well, and we have the ongoing SLDHA one. And we have some too, because again, we have this composite / dual signature one. We're not quite sure what we're going to do. And we also have a McLeese one. So the gentleman who was the author of the draft did send it to the mailing list. It got like no reviews. And then he said, well, I'm done. So let's go to the ISC. And then the ISC came to us and was like, you guys should think about this. So we're going to have to think about it. We're going to have to slot it in somewhere to figure out how to do that. But I don't know if you know much about McLeese, but the keys are bigger than the handshake, the initial handshake window. So we have to do something about that. So we'll see, and we'll have a discussion about that. All right, so the next upcoming things that are going to happen with these PQ algorithms are, remember, we're not picking an MTI. I'll repeat that a couple times. Just remember that. For each of the IDs that we're doing for this, we're going to have some questions, right? And so we've kind of figured out, like, if we've adopted these drafts, how fast should we move them? And so for the timing now, like the hybrid one is going to go very soon. The pure ML-Chem one, we're going to think is going to follow right after that. And then later, we're going to do however many signature ones we have. And then even after that, we're going to do the dual cert / composite ones. But when we do all this, we have to decide for each one of these, is it informational standards track? Because that opens up what the recommended value could be. There are a lot of people that have told me, just leave the drafts the way they are. They're informational, and they say no, and we can just leave it alone. And there are other people that are very adamant that it needs to change and needs to be standards track and made why. So we're going to have to do this for each one of them. I apologize, it's life. We're just going to have to go through it. There's been some discussions about applicability statements, and so we're doing that with the SLHDSA one. We'll have to figure out what we're going to do for any of the other ones that come along. There's also been some security considerations. We have to figure out how deep down the rabbit hole we want to go. So for example, for the ML-Chem one, we rely on a CFRG document, but there might be people that want to put words in one draft or in another that kind of want to lean you towards the other answer. So I'm hoping that we can come up with some pretty generic, hey, cryptography is hard, don't do it yourself. Use good algorithms, like kind of generic motherhood and apple pie things. And then you should really think about one or the other and maybe cross-reference each one of the documents so people can, figure it out. So, and that's it. So I guess, are there any questions about the status? Does anybody want to challenge anything? Tell me I'm wrong. As if not, Stephen, you're up. Oh, I'm sorry, I can't see that.
Sorry, I messed up and didn't sign into MeetEcho yet.
Yeah.
Could
Tom?
share Tom Wiggers. Sorry, I should have started with that. I'm very confused on when we're doing an RFC and when we're not doing an RFC and just going directly to the
Oh, you mean going through the FAT process?
No, no, not for FAT, but for PQ algorithms. Because we seem to be, maybe this is a me problem, but we seem to be flip-flopping between, no, you can just go directly to the IANA registry and
that's 2 points.
Writing a thing.
So there's 2 points, right? They can get registry entries before, because of the way we set up the registries. So the minute you write a draft, you can go get code points. Anybody can do that. Whether you're going to then take it to standards, down the standards path, that is the question about how you would do that. Everybody, we could stop. If the working group is like, we could stop on all of these. I don't think that's actually going to happen, because there are a lot of people that are interested in these things. But
yeah, because I'm seeing the same discussion every time one of these new things is being put forward, and I think it would be helpful if we sort of establish the way to do this.
Paul?
Hi, Paul Wouters, 80. I tried to do this, I failed.
Yeah, I mean, we tried a little bit and it fell on its face. Because everybody wants their thing, and then a lot of people, it's clear, to me, it's very clear what the consensus thing is going to be, but then the fringe ones get a little interesting.
Watson?
Hi, yeah, Watson Ladd, Akamai. I think my point's been made by the other speakers that there is a lot of confusion here, but I do think we need to step back and say, okay, what is it that producing an RFC describing a code point and also in CFRG an algorithm, what's the value that has to the internet community? And what are we trying to do by having that process? Because I think there's a non-zero number of people who think they need an RFC to go deploy the thing. And that's not the case. And certainly would be a mistake if, in my mind, if we had a lot of widely used things where there wasn't an RFC saying how you do it for all the reasons of openness and have everything in one place. And, we've also in the past decided that we're also going to shade, okay, yeah, you could do all these things, but here's the subset that we want you to do. And I think we should sit down and pick through how that applies in a more principled way at some point, just so we can tell everybody and be like, yeah, this is what you need to do for what and why you might want an RFC and why you might not want an RFC.
Yeah, I think that's maybe something we can add to the FAQ.
I mean, it is, but unfortunately, as Paul noted, he's tried it, right? And so I figure if we try to do that larger thing, it is going to affect, it's the whole IETF process thing, right? So.
All right, Ecker?
Yeah, so I think, as Paul said, there is some dissent about what exactly, or disagreement about what exactly the standard ought to be here. The facts, as Watson said, are that you can have a code point without an RFC. That's just the way it is. I also think, maybe we don't have to rehash these discussions at every single adoption call. I guess I have two suggestions along those lines. The first is, perhaps we could agree, given given that we're operating descending order of sort of demonstrated interest, perhaps you could agree that all of these remaining ones will be, if accepted at all, be informational, and we'll have n in the column rather than having to debate each one individually. And perhaps people, me included, could restrain themselves from actually redebating the substance of whether an RFC is needed on these adoption calls, and just sort of say yay or nay, and that might allow us to not have to rehash it so much, and just assume that everything that can be said about that has already been said. And I do realize I'm an offender in that respect as well, but perhaps we could all just do that, and that will allow us to have this be a slightly simpler process.
Yeah, so I do try to strongly hint sometimes that when we do an adoption call, it's yay or nay. It's great that you would provide input, but that's really sometimes not always what's going into the decision or helping drive the decision. So yeah, I'm hoping that, essentially the practical aspects here, if we're pausing the other ones, we can, and we know that we're being overt here about the ones that we're gonna, pause essentially. If we do adopt the drafts, I'm hoping that's the same thing. And then maybe we revisit this stuff later. But I do know that there are a bunch of people that are going to be, hot to trot on the hybrid and composite stuff. So we'll have to see how we do with that. But yeah, fair point. So, all right. Cool. Stephen?
Okay. Oops.
Right. Do you have slides? Yeah. Oh, he does. I didn't know he had slides. Is this him? Hold on. I gotta do this. I gotta pass slide control. Say, yes, I'm gonna take over slide control. And then I do this. No, I don't do that. I do this here. Sorry.
It's not to share.
Do you want take back with this like yes. And I go pink. Stop sharing the slides. Share the slides. There you go. Confirm the slides.
Okay.
Then I go over here and I give you that. Sorry. There we go.
Okay. So we've done this a number of times before, so I'll go pretty quick and to keep in the 5 minutes. This is a draft we've been working on a few years. It does that. That's all the same as it has been always. There's a picture in case we need it. State of play. So this previously has bounced around between dispatch and DNS op and so on before it came back here. The authors think it's ready for working group last call. There's an implementation, kind of works okay. There's an example of what you get. And there's two open issues since we published draft 8. One is just a kind of a definitional thing, which is easy. The second one is just to be a bit more precise. Basically, we say when you're about to publish something, you should check if it works. And then there's a little bit of imprecision in that, so we can fix that. And then there's a bunch of recently closed issues, none of which we will need to talk about, except number 44, perhaps. The idea there was if you're this zone factory entity in this picture and you're trying to verify something, it's not unlikely that the zone factory is also the authoritative server that has the CAA record. And so if you are in that position, checking that might actually add some better assurance as opposed to not checking it. Ben pointed out that this is kind of a little bit in conflict with general behavior for checking CAA or not checking CAA except at issuance time. So people might want to object to that, in which case we just take out the sentence. Otherwise, I think it's ready for working group last call. I think Rich and Ben similarly agree. And I would guess if that's going to go ahead, I think at some point you kind of said you'd go back to the DNS op list as well or something, but you don't have to. Yeah.
So on that point, we can ask for director reviews. So I think we can just ask the directorate,
we already had early reviews or whatever. But
all
yeah,
right, we did all that. So we can do that again. But I think the point was we had to get people to read it. Somebody read it because I asked them specifically. They did, and they said it wasn't crazy. So that's good.
Okay.
So I mean, the only question is, do you want to wait to resolve these two last call issues? And so
no, I think we could go ahead.
So this is a working group last call issue, and then we will close them if nobody says anything in the working group. Okay.
Yeah, that would be my preference. Yeah.
Ecker?
Are there any deployments of this?
Just mine, as far as I know.
Okay,
Just a
so
test deployment.
sure. So in the past, I think we've been pretty reluctant to just ship things out of the working group without any real deployment experience. I think one thing we've done is press the working group last call button and then sit on it until someone actually deploys it. I think we should either do that or not working group last call it. But I think we should not do is ship it as an RFC without some real deployment experience.
Fair enough. I tend not to agree but there you go.
David?
David Adrian, Chrome. First of all, just want to be clear, I'm really supportive of this draft generally. I was surprised to see the request for working group last call because I went through and was reading it this morning, and there's obvious applicability to other things that Chrome has suggested that would go into HTTPS RRs like TAIs. The draft seems to be entirely about EC, referencing EC configs, and then you go look at the JSON structure and it has every single field in the HTTPS RR, which granted I think is a good design, but I was surprised that the introduction seemed to not be about what the draft was. And it also, it's not clear to me, if you have a CDN setup, should the zone factory be trying to hit the CDN and then getting back one of many different .well-known files, or should each thing the CDN is backing, should you be configuring the zone factory to try to hit those directly? So I don't know, in general, your draft, your call, but those were some things that I might take a look at, and generally, supportive of the whole idea. I think lots of applicability of getting data into the HTTPS RR, since not a lot of out-of-the-box systems have a path to the DNS server from the HTTP server. Thank you.
So if getting those comments processed means doing working group last call a bit later, that'll be just fine. Be delighted to take them. I think I've gotten some input, but I don't think we had it. Well, maybe we just didn't prompt you hard enough to try and
send the input now. But yeah, if you're happy to kind of say you'll sort of send some comments or text,
Sure,
or
I can
issues or
send the
whatever.
comments to the list.
Yeah, if then we can do the working group left call after we process that. That'll be fine.
Rich?
Yeah, as the non-speaking author,
You are
Ben-
speaking as it happens.
yeah, but I'm not up there on the big stage, and I don't resent it at all. David Benjamin had pointed out that this thing was more generic, similar to the arguments David made, and we tried to make the minimal set of edits to do that, and it looks like we didn't catch and make it explicit enough. So yeah, let's.
Yeah, absolutely. If there's more to put in, happy to do it. Yeah. Okay, so it sounds like we're hoping for some mail or GitHub issues or something, and then come back and ask for working group last call again. That's okay.
Yes.
Nothing else?
That's it. Thank you. All right, now we have.
I think it's Yaroslav
Yep. Extended key update.
or Hannes. We have extended key update.
All right, here we go. I believe I'm getting better at this. Yes. Third time's the charm. Got it.
Hello, everybody. This is Yaroslav and Hannes. So this was supposed to be a very boring, quick presentation until last night. And last night we got an awesome review by Ecker. So thank you very much for doing that. And we will address some of the points that he raised during this presentation. Ecker, we're going to quote some of your review, and if we misquote you or do something out of context, please do interrupt us and let us know that we got something woefully wrong. And thanks again for your review. So to recap, what is extended key update is about. I mean, traditional key update with classic or standard key update, if your virtual machine or a process is compromised, that is, somebody stole your memory and got to your keys, then your established TLS sessions are compromised until the end of time, until you terminate that session. And new key updates do not, well, your attacker could derive fresh secrets that would be got by future key updates. Attacker would not be able to derive secrets from before previous key update until compromise happened, and extended key update reduces somewhat this attack surface. So compromise is still a bad thing. You still get some potentially confidential data stolen, but once extended key updates happen, then previous keys are completely invalid and new keys cannot be derived just by doing something with old keys. Now, the first bit of feedback, I'll let Hannes address it.
Yeah, we've been trying hard to describe the security properties, as Yaroslav just mentioned. Specifically, we were sort of trying to weasel around the word forward secrecy and what exactly the properties are. Specifically, since there are different types of keys at work, we have the long-term keys, but we also have the symmetric keys that are used. And we went back and read RFC 7624, which Bruce Schneier and some of the folks here in this room wrote, which talk about or make a distinction between a static key exfiltration and the dynamic one, where the attacker constantly needs to sort of retrieve memory with the symmetric keys as these key updates happen. And so we are trying to force an attacker to provide this or do this dynamic key exfiltration. And we've been trying hard to find the right terms. We thought that post-compromise security, as briefly mentioned in the appendix of the TLS RFC, isn't the right term because at least the cited reference there is talks very generically about the compromise of key and doesn't distinguish the long-term key versus the symmetric key or any other keys. So we probably have to come up with some sort of better definition or better description to describe this sort of property that we are accomplishing here with the forcing the attacker to do a dynamic key exfiltration.
All right, so you asked a question on the slide, and there are 3 people in the queue. So Tom.
Okay.
Tom Vickers,
Okay.
as a protocols security person, this is exactly post-compromise security, what you are proposing. And that is actually quite often done only with ephemeral key exchange. If we, for example, think of the signal double ratchet algorithm, is exactly the same type of scenario. You're compromised, you exchange fresh ephemeral key material, and then you reestablish security. Not forward secrecy, we call that post-compromise security.
Yeah.
Forward secrecy is about whether you can, like you said, compromising long-term keys, compromising the ephemeral keys, not both at the same time.
Yeah.
That's not what's going on here. This is only about the ephemeral key exchange that's happening. And this is just exactly the same as in Signal, as in all of these other continuous group key agreement protocols. Post-compromise security is the just...
Yeah, glad that you mentioned that, because I also read these specs again, and funny enough, they don't define the term precisely either. So when you say we define, it's actually not well defined. If you look at Signal, the Signal specification, and try to find the definition.
I think that is largely because that predates all of these scientific papers that were written about this. If this would be a paper submission and I got this like on the Asia Crypt queue or whatever, I don't think any of the reviewers would say that this is forward secrecy. They would all say this is post-compromise security.
I think what would be useful, like if you have some text, I'm happy to include that text to make that clear, as long as it sort of provides the properties that we are trying to do. And specifically, I like the work that was previously done on the by Bruce Schnei and Richard Barnes and some others here. And I think then that would be perfectly fine. So we didn't just want to sort of just put that there and left the reader puzzled about what keys we are talking about, because specifically if the long-term key is compromised, the whole story gets very complicated. And I don't think just doing then a Diffie-Hellman afterwards will make you create you a lot of benefits, to be honest. Because I can impersonate you when I have your long-term keys, right?
Yes.
Which is different than Signal, because there you can argue, hey, it's a chat, and if someone does something funny there and so on and so on. But
you could impersonate someone with long-term key in a new handshake, I think, in your scenario.
Yeah. So that would be not good.
Which would be not exactly the same kind of scenario. It's been sent to the FAT to review this afternoon. I don't think that I will be the only person to point this out there as well. I will see the text when I do that review and probably put something forward at that time.
Good. Perfect.
Right. John?
I think you should try to use forward secrecy and post-compromise secrecy as little as possible. My experience is that using these type of cryptographic terms lead to a lot of discussion and not very useful discussion. I would try to, as much as possible, instead say that compromise of key A not allowed an attacker, passive, active, to compromise key B, and then repeat that sentence.
Yeah. That's exactly what I've been trying to do after the discussion we had last time on when I used forward secrecy.
Dennis Jackson. Yeah, just to back Ecker and Tom up. So I think you definitely mean post-compromise security. In terms of history, Signal came along first as a protocol. Then the notion of post-compromise security came later.
Yeah,
but was coined like specifically after what Signal had done. So yeah, I think, looking back at these things, it's always very messy looking at academic literature, but it's definitely post-compromise security you want, but you're describing it already literally. So I think it's literally just a find and replace for forward secrecy with no other changes required other than that label.
Yeah, happy to work with you on some text.
Ecker?
Yeah, so I think I agree with Dennis and John to some extent. I think that it was clear from this document what you're trying to achieve, and it's a coherent notion, and it's just a matter of what the words are. And so perhaps we can workshop this with the FAT or whoever, and someone could get it done. But I don't think this is only an editorial problem from my perspective.
Okay, second kind of part of the review, simplification of conflict resolution and rejection. Now, one suggestion was to just completely get rid of retry and require immediate response because key exchange is relatively cheap. This is something where we respectfully disagree because there are some situations where key exchange is not cheap. So those are the numbers that I measured really quickly in the lab, so they don't take them as some kind of ground truth. But P5 to 1 on single core of Xeon, pretty powerful Xeon, still it's like in hundreds of operations per second. So if you have a botnet and you do extended key update all the time, you could potentially do DDoS with that. So we believe that we need to address. And then, of course, Xeon is relatively powerful CPU. There are people who implement TLS monitoring on Java cards and the likes, where I'm sure they have a bit lower numbers. Second option that Acker suggested is to allow the responder simply to unilaterally delay, and that simplifies state machine. I think in general, we like this proposal. I believe there was another response on the list that supported that. And yeah, I think this is something that we will implement in the draft. Any objections to that?
We have a couple of people in the queue. Deirdre? Oh, no, sorry. Oh, yeah, you are.
Go ahead. I had a question previous. Go ahead.
Anyone else in the queue?
Okay, Martin?
I'm looking down the barrel of a camera here. So I tend to think that an immediate response is the simplest thing to do, and the delay is a bit of a defensive mechanism. If you're under attack, close the connection. This idea that you might just continue to respond to key updates that are beyond your ability to service them is a little silly. There's any number of ways that these protocols can be abused for that sort of thing, and this is a new one. Obviously, you have to document it, but I would start with an immediate response with some amount of delay. Obviously, delays are always going to occur, and particularly if you're using P521, I mean, the other answer there is don't use that. But I think this is probably fine.
Not sure if I heard everything.
Okay, Tira?
Thiru, Nokia. The cost of power utilization and other resource utilization would significantly increase with PQ camps and hybrid camps. So I think retry mechanism makes sense to delay the process if the server is loaded, so that if all the clients can ask for a key update, then the server can basically decide when to do what.
Michael Turkson, Münster University of Applied Science. Delaying the response simplifies things over reliable transport, but if you are running it over UDP, you need to ACK it and delay the response. I mean, you need to send, I received it, but I sent you the response later, because if you don't do this, the peer will retransmit the request.
Okay, Ecker?
Yes, I agree with that statement that Michael just made. To be honest, I did not, in fact, go through the entire DTLS section. My plan was to because I felt like we had a number of issues that might change the state machine. I didn't really want to think about the DTLS parts of it just yet. So I think, but I don't think that actually creates a problem for the perspective of the system, because at least in a standard detailed implementation, at least the ones I've worked on, like the retransmit state machine and the overall state machine are kind of decoupled to some extent, and so it's like really, it's like having to go back and be like, I got to try again in 25 seconds or whatever is like a really different problem from like that. Does the message get received? And it's true and quick too, I think. So I tend to agree with Martin. I think I was sort of like, I was kind of just gesturing of like, you can kind of pause, but like, I think generally, like if someone's like sending you a ridiculous number of like retry requests, probably like you should turn it the connection rather than like try to like damp them down.
Okay. So the next is hopefully pretty straightforward. Handshake messages are, we don't have, as it comes, infinite pool of message IDs. There are actually less than 226, whatever the number is. So we are currently asking for 3, and that's probably too many. We could use just 1 and implement some kind of type just to conserve number of handshake message identifiers. We're generally okay with that. Anyone have any objections to reducing number of messages that we define? I guess not. And then the most important probably thing is changing to the key derivation. So we changed something in 0.5, and Hannes is going to talk about it.
Yeah, so the key derivation procedure, one aspect here you may notice is that the labels include, I sort of also changed the labels being very conservative, although 2 other places are there that are different from the original TLS key derivation function, namely, first of all, the previous master secret is provided as input, and then also, of course, since we are doing for the ephemeral Diffie-Hellman exchange, we also are feeding in the symmetric key that was derived. So we have 3 places that are different, and so the chances that there is a possibility to produce the same keys or somehow confuse the key derivation is minimalistic, I would say. Maybe I went a little bit sort of overboard with also changing the labels. I think that's probably not necessary, and as Eka pointed out, so I will reverse that because the other 2 things are already sufficient. And on top of that, we, in the latest version, version 5, we also indicate that you can't mix the extended key update with the regular key update. So that's so there's no attack that one could mimic or reuse some keys there, which is this one. Yeah. Okay. Next. Oh.
Yeah, I just want to flag that I did not double check this very carefully. So like I think I'm right, and you seem to think I'm right. But it'd be helpful if someone else made sure I was right. But I think assuming there's no other way to get down this chain than via this, then I think it's fine to have the same labels, and it'd be nice not to have the leaf keys have different labels because you can modularize that component.
David?
Can you go back to the key schedule slide? So it's interesting that you chose to cycle the exporter and resumption secrets because that's not something normal key update does. And doing so is a little interesting in terms of like, so when you get a new, when you get a new session ticket, you've got to know which resumption secret it's using.
Yep.
And so I guess we can say that it uses the one from the epoch it's in, but now in a TTLS implementation, you have to keep multiple read epochs alive. So now for every epoch, you've got to keep an extra resumption secret around just so you can like properly parse the tickets, unless we say that like, okay, you only keep the last one and you just drop the ones that you don't care about, but that's like a lot of extra stuff. Likewise, the exporters, like exporters are something that the application sees, whereas the key update stuff, at least in most TLS implementations I've seen, is kind of transparent to the application, so you don't actually know when it's happening. But it means that like, suppose your protocol is defined to like, you know, you exchange, you use the exporters to derive a channel binding and you like sign something with it or whatever. But due to the order of when you call the functions, one side derived it out of the original exporter, and the other derived it out of the later exporter, which is very easy to have happen when you have key updates be like part of the transport because the application doesn't see key update state. So this seems like a mess in the making.
So indeed, first of all, we did mention exporter key previously, but we were not specific about how it's changing. Resumption secret is something that we didn't really think about until we started doing prototype implementation. Now, the problem, of course, with not changing exporter and resumption secret, that it not doing that is kind of defeats the purpose of extended key update, right? So if you compromised your master secret, and then you did extended key update, but your resumption secret stayed the same. So, well, you can just use the previous resumption key and get into the session even after you performed extended key update. So we expect that previous resumption secrets will be invalid. And when it comes to exporters, indeed, that will affect APIs, and in some cases, application logic that need to take into account that exporter secret can change when extended key update occurred, and plan accordingly.
Okay. So
there is really no way around it, is there?
I mean, the other way around it is to not cycle them, because the resumption secrets are already like off on a different key schedule anyway. So if you break it, you can't go back, and exporters are kind of a mess. But anyhow.
Yeah, we added text on this also in the latest version. So it's definitely something we want to have input on. Also with the key exporter, because we are in one of the last slides, which we won't be able to get to, there's some references to some work that depend on this, and they actually utilize that newly derived keying material from the exporter. So that was one of the reasons. Otherwise, if you would call the exporter multiple times, you will always get the same secret. That is, although you have been updating the keys, you wouldn't get anything new.
So just in terms of time checking, no, I don't think you should get off the stage, because this is a working group document and it's having a good discussion. So we're going to keep going, but we're going to try to add 5 minutes. So people try to keep it short so we can try to get through all the presentations. Thank you.
In the key schedule, it seems that you're deriving the transcript encryption keys, actually all of the derived keys, with a transcript context of only the extended key update instead of appending the extended key update to the prior messages in the handshake. Is that not a change from how traffic keys are derived in TLS? Because now you're no longer binding these keys to all of the things that happened prior. Those are the things that protect us against things like re-encapsulation attacks. This might not be an actual problem here, because you've done like a bunch of AEAD message exchanges before, so maybe that's authenticated, but all of that invalidates the way that all of the proofs that I'm aware of for TLS 1.3 how those work. So we would need to do everything from scratch again. So can you please derive the traffic keys from the entire transcript?
We could, that's true. We could do that. So currently, as you correctly said, like we fold in the master secret from the previous session, and then we include the transcript from the newly exchanged messages, but not the entire sequence. We could do that. Yeah.
Yeah. Unfortunately, the main secret of the handshake only has the input from the key material, and it's only the traffic keys in which the transcript is folded in. So by deriving it from the master secret, you're unfortunately not taking along with you the context in which that key was derived. That's just the way that things were set up at the time. I don't know why that was the best choice, but that is how it works.
Yeah, that's good feedback. We'll think about that. Thanks.
Kyle?
On the resumption secrets, I don't think I have a strong opinion one way or the other, but I do think it should be really well defined what happens to the old ones in either case, if they're updated or not. Right now, looking at the draft, there's like kind of a suggestion that they're discarded on the server side, but not really specified on the client side. If we do want to update them, my guess would be we want to entirely ban use of the old ones on the client and the server.
Yeah, I didn't want to go all the way to ban them, because you could still, depending on how long the period is, you could still reuse it within that period between the key updates. That would be still possible. But and it would be dropping, then invalidating, and of course on both sides. But you're right, that would be another approach to just not use them all together. Of course, sort of if you want to have the security features, there comes some performance disadvantages, so to speak, that come out of this. But I think that's bad luck, right?
Yeah, I guess I think like if we do not forbid use, then it kind of calls into question why we're rotating them to begin with.
So currently we are not. So the text doesn't say we forbid them, but it says if you do the extended key update, you invalidate them.
I think it's important that you keep the ability to derive new exporter secrets. That's a thing you could do in TLS 102, then it was removed in TLS 103. If it's complex, maybe you need to define a new API. I don't know, but I think the ability to do that is important. And then I think the suggestion to derive from application traffic secret N is a good one.
Okay.
All right, cool.
I think we're done.
You don't want to go, I mean, sure, we could, there are more slides and more things, but obviously this is a point of discussion. Please discuss on list. That would be great.
Just one final thing. Again, thanks, Ecker, for thorough review. We're looking for more reviews. We're working on some implementations. If anyone else would like to join and work on implementation and to do some interop tests, that would be highly appreciated. Thank you.
Hang on, don't get off the stage. I'd like to resist terminating this discussion. There are other things to talk about here, and the way this works is working drafts have high priority. Push the things that are not working drafts off the agenda for tomorrow. Don't cut short the working discussion.
To be clear, I'm okay with that. So I just, if you want to keep going, we can keep going. We can.
We have plenty of time when you add up today and tomorrow. It's just that the people who have working group drafts, non-working group drafts get pushed off, and that's the way it's supposed to work.
Oh, we can definitely talk more. There are also, which we don't have on the slides, on the GitHub repository, working group GitHub repository, we capture the open issues and have also filed some PRs on addressing the open issues. They were mostly about sort of things to do items rather than necessarily issues per se. But for example, the DTLS description, the DTLS 1.3 description for this has been very brief. And so we took an attempt to write some text for a future version, of course, pending reviews. What else do we have on the slide deck? Eka, do you have some other issues?
Didn't we have the conflict? The clash?
Oh, the clash. Yeah, let's go back to the clash. Yeah, you had it. One, yeah. This.
Oh, right. Yeah. So one piece of feedback that I missed. So we have clashed response code. So when two parties try to do extended key update at the same time, and at the same time we also define who should win. So actually there is no good reason to signal clash, because both parties, if they are saying no, who wins and should act accordingly. And if one of the parties is insane, then the other, of course, should terminate their connection, as you do with insane parties. So yes, that's great feedback. We plan to remove clashed response code and just let parties act according to the specification. Anybody disagrees? Okay, we have some people in the queue.
Oh, I was in the queue for something else because it sounded like we were waiting to discuss things. Although I guess my one comment on this is, are we sure this does not cause a deadlock? I don't know what the information known on both sides is, but if each one is waiting for the other, we will have some issues.
No, they're lexicographically sorted. So as soon as you see the other one, you know who's rejected. You know who won.
All right. Yeah. I don't know procedurally how to do that. I'm in the queue.
I think
we're done with the slides, but then we wanted to talk about other issues.
Okay.
Victor, are you in the queue for this topic or for?
I'm in the sort of general thought on the slides that have gone by so far, so I can wait if this is the hot thing right here.
Okay, then let's get David going first.
All right. So the comment I had was, so I looked at the protocol flow, and so you all have a a request which carries a key share, a response which carries a key share, and then both sides exchange a new key update to actually apply it. Do we actually need all 4 messages? It seems 3 is sufficient. Like, I think you need a request and then response. And as soon as response is through, like that gives you enough to derive the key. So you should be able to, so in TLS, you should be able to, at the response side, go ahead and switch the, and apply it on the acceptor. And then the new key update is really I would like to act your response. And then that's when you apply it on the initiator. DTLS is a little trickier. It has been a while since I had the disaster that is DTLS in my head, but I believe it shifts everything to the next message on an ACK, which would mean that you wouldn't want to, the 3 messages are still fine. Rather, the response doesn't get applied until you see the 3rd message, and then the 3rd message is applied when you see the implicit ACK, or not the implicit, the explicit ACK for the last one, because in any flow, DTLS 1.3 is always going to add 1 more flight than there normally would be. So if you need 4 for DTLS, then you want putting 3 in the protocol is correct, and so on.
Yeah. The current design is based on what we basically discussed and agreed on at the Brisbane meeting, and we had a presentation back then, and the argument back then, if I recall it correctly, was the symmetry.
But the symmetry thing means that you need to like buffer the secret lying around for like a round trip, which, I mean, DTLS 1.3 is going to need to do that anyway, but I think
in TLS you don't.
In TLS, I guess you get to shift it up by like half a round trip, which like may as well, but.
So you don't need to.
I think you don't need to apply. I think you don't need an extra message on the acceptor.
You would
side.
get away with 3 messages.
Yeah, I think you need 3, but I don't think you need 4.
You don't need 4, but then you lose that. So if that is not a concern to have, like, that was the feedback I got last time. So of course things keep changing.
I think the thing I've been sketching out has always been 3, but like I've like probably missed some other parts of the discussion.
Yeah.
All right. Well, anyway, that was the one comment I had.
Okay, Victor. Oh, Valerie, sorry.
Valery Smyslov, Willis Plus. I think that this mechanism is very similar to the IQ2 mechanism called rekeying, and with regard to clashing, in IQ2 it is called simultaneous rekeying, and there may be a rather complex situation if your transport is not reliable, in this case in DTLS. So I just suggest you review RFC 7296 IQ2, because it is described some interesting situation when packets are delayed, lost, and so on. And there may be rather a bit complex logic for developing, for determining which side to win, because it is possible in IQ2 that one side already completes the rekey, and the other thinks that it sends something, receives nothing, and so that's on. Just to pay a bit more attention to the situation. It can be rather complex.
Yeah, thanks for the hint, Valerie.
Victor?
Sure. So at the beginning, we talked about, frequency and delays and all of that. And my question is, does it really make sense to do this much more frequently than the session key lifetime of resumption secrets? Because certainly in a clustered environment, if a server has periodically rolls session ticket keys, let's say once every 5 minutes or every hour or whatever, then the entire cluster is willing to accept comparatively multi-minute old resumption tickets, and there's no practical way to instantly revoke them across the entire plant when a particular connection using the resumption ticket happens to do this kind of negotiation. So it seems that we have a natural sort of time window that sort of sets the pace in which it makes sense to do this. That is, if you have a 1-hour resumption ticket lifetime, doing this kind of rekeying every 5 seconds or even multiple times a second makes no sense to me. Do you have any thoughts about that, or am I misunderstanding something?
Yeah, so we don't we don't say anything about the lifetime or the frequency of how often these key updates would be done. But based on the early discussion we had about the resumption tickets, I'm wondering whether the easiest approach is really to say you don't use them if you want to have these security properties, because that would probably make the whole implementation and the coordination easier.
And it also, that trigger to extended key update could be something way up the application layer. So it could be something risky has happened or some authorization property have changed, and that could trigger extended key update rather than any timer on transport layer.
Would you see that as would you have a problem with that, Victor?
No, but if it's really triggered and infrequent, right? If it's driven by external events, one doesn't imagine it happening, repeatedly and frequently, right? If a client wants to do this multiple times a second, but there are being issued resumption tickets, that last minutes, something's not quite right. So maybe some language covering that, or if in fact it makes sense to not do resumption when this technology is in use, I don't know. But please explain how these interact. Yeah.
Okay. That point taken.
Watson?
So I'm also going to ask about resumption. If I remember correctly, the TLS 1.3 resumption always does another key exchange. Always, so it's really just skipping over the cert verification step. And then there's an interaction with 0RTT. And it's not, if our model is that we might have compromise of the traffic keys at some point, but not secret data from the initial bits of the connection, then I think it still makes sense to honor the resumption ticket even when you do this. On a different note, it's going to be difficult. Well, I guess you can resend the tickets later on for the new epoch, but I don't think the secrets you would send would change unless we're changing around certain other values that have been sitting around for a while. And this gets into the interaction with exporters with forward secrecy, which is really kind of ugly, where if we're changing the exporter secret, this can't happen quietly behind the application's back because values it derives and might process at some later time and do all sorts of crazy things with are suddenly invalidated when you do this. So that's another area of interaction that needs to get fleshed out and thought through.
Ecker?
Yeah, I mean, I think the point I take Watson making is interesting. We do of course allow PSK only resumption, but my understanding is that's extremely uncommon if it exists at all. I actually don't know how to. I actually have to think quite closely about how to reason about the post-compromise security behavior of in this situation, because if you in fact do, forgetting about 0RTT for a second, if you just do a new handshake and then a Diffie-Hellman at the same time, that effectively is post-compromise security in some respects. But the authentication is goofy. And then the question is are these resumption keys being held in different memory from the keys that you use for to reestablish the session? And I guess maybe you have to worry about the client being compromised, not the server being compromised. So I think trying to reason about that is very difficult. I'm not sure where that gets us, but I think it's an interesting question to try to figure out what the properties would be that maybe some people with much better tooling than I have could figure out.
All right, that's the queue. So that's the drains the queue. So good. All right.
Yep. Thanks for the feedback.
John? Yep, off the hook. Thank you very much, gents.
Slide control.
Yeah, I was overly generous giving time. So.
Thank you. So this is about large record sizes for TLS and DTLS, and hopefully might not need a 15 minutes. Let's see. Co-working by me, Hannes, and Michael Tuxen. So what has happened, it was presented at Brisbane. There was a lot of discussion and comments at Brisbane, and the major rewrite based on these discussions. So what was the changes? In new independent extensions, large record size, instead of a flag extension used together with record size limit. This new large record size extension works like record size limit, but allows larger records up to 2 to the 32 bytes. This comes with a new record format, TLS large ciphertext. There was a comment in Brisbane and on the list that if we do this, we should choose a big enough size so we never have to do this again. And 2 to the power of 32 bytes is probably enough. The new record format comes with a variable length field, 2 to 4 bytes. So you can have 2 to 16, 2 to 24, or 2 to 32 bytes. Otherwise, everything works like record size limit. You advertise the maximum and negotiate the maximum size you're willing to receive. And as it uses a new record type format, it's not compatible with middle boxes expecting TLS 1 or 2 records. Also, a lot of grammar and comprehension tweaks. Has not been any changes since adoption. It has been quite stable. I wrote here no new known issues, but after writing that, I noticed that Ecker commented on the list. I will come to that and discuss that. Here are the record sizes, how they look like. So they have a variable length field that can take 3 values. And to the right is the DTLS version. Comment from Ecker was a minor comment that we should explain that this is how this relates to some of the terminology in TLS 1.3 to make it more explicit. And then Ecker suggested, if I understand correctly, to make the variable length, the length field variable would need some extra bit. I think there's benefits and disadvantages with that. If you have a very fixed size, it probably adds more bytes unless you can use some existing bit. If you have variable length of your record, it would save you. I think that would be Ecker pointed to CTLS and quick. I would need to look that up. But I think that was the major technical suggestion, to make the length field variable in some way. And that's basically it. Draft has been stable. I think that's the only known issue, to make the length field variable in some way that might save. We have implementation in progress by Hannes. If you click on that, you will come to a GitHub where that is open source. Ericsson has decided, Ericsson products have decided that they will support this in the future for some internal interfaces. But I would need to check up what the implementation status is. I think what is needed is solve this issue and more reviews, and then I think we are quite ready for working group last call. Ecker.
Yeah. So as you say, the way Quick or TLS does variable length fields, or variable length integers actually, is just by stealing a couple bits from like the top to tell you how long the thing is. The trade-offs are exactly the ones you expect, namely that some things right near the edge of like 2 to the 16 get a little longer by 1 byte, but and you can't express the very top of like the giant 4 bytes, but on there 32 bits. But on the other hand, like the average records probably get shorter unless there are a lot of things in the cliff. So that's kind of the trade-off. I was trying to remember, maybe Martin does, whether quick variable length integers go to 64 bits or just 32. Although I can't imagine any sane person wanting. And honestly, I can't really. Even having like a 4 gigabyte record seems like excessive because you can't really process it until the AED is finished. So it's just hard to imagine why we'd ever want to go bigger than 32. This is like I certainly wouldn't. Like I think we should just we should take a sense of the room and do one or the other and like call it a day. I'm not gonna like go to the matter for this, but I just read it and I was like, I thought I would do it the other way.
So that is the queue. I guess I'm trying to figure out, Martin.
Yeah, I wouldn't. The massive echo here. It's almost enough to stop me from being able to speak. So quick goes to the 62. That's ridiculous. There's no point in. The AEADs generally don't have a counter that would allow that. I think you'll find that. What is it? They steal 16 bits. So that's less than 2 to the 32 in a lot of cases for a single. I forget. Doesn't matter. I tend to agree with Ecker on this one in terms of encoding. I couldn't make sense of the left versus the right here. The encoding here in the picture don't really match up in my mind.
The left is when you negotiate this in TLS, and the right is when you use this extension in DTLS.
Right, and so Ecker's point being that if you negotiate it in TLS, you're fixed, and if you want to have the option of sending very large records, you pay an overhead on every record that you send, even if they're small.
Yes.
And so
both yes and no. You could have it variable, but it also removes 3 bytes of compatibility bytes. So the actual overhead is less than today, but it could be even less. Yeah.
Right. So I think I prefer Ecker's proposal. If we have the bits to steal, they can go in that first byte. If not, they can go in the field itself. 2 to the 30. If you're stealing 2 bits from an integer, 2 to the 30 is a pretty big number too.
Yeah.
And probably would meet your needs. So I'd suggest probably doing either one of those, depending on what's available in the header.
Mm-hmm. Sounds reasonable to use 2 bytes for that, and then support the maximum of 2 to 30. I think that is enough for everything. No.
All right, cool. So it sounds like what we're going
to discuss on the list.
Yeah, discuss it on list. Get a PR in, and we can go from there. Thank you. All right, who's next? PQ. All right, Deirdre, it is you. I think I'll share the slides, and then I think you can you request control?
I don't think I can.
Okay, just say next, and I'll make it
All
happen.
right. All right, this is an update on MLChem only key agreement for TLS 1.3. Next.
There we go.
I should have updated that. This is the other side of the hybrid key agreement that is in its final steps of IETF last call. It was adopted around the meeting in Bangkok. This is just trying to do, if you like MLChem by itself, you can use it. And next slide. These are the code points that got registered. Next. And this is how the IANA registry exists. We are not recommending it. It's just N for all of them. That's how it is. Next slide. Oh, that's wrong. That should be hidden. Next. Next. All those slides should be hidden. Next, please. Okay. I just pushed out version 2 after some good reviews from Ecker and from Scott Fleur. A lot of it is a lot of text that was kind of lifted from an academic style of writing that is definitely not needed when we have a very specific primitive that we're using and very specific parameter sets of it. So a lot of like caveats about lengths and properties and bounds and things like that just don't apply. So a lot of these changes have been removed. So we had an unused normative ref, removed a section about the requirements of fixed lengths, which this construction obviously fulfills. So why are we talking about it? About how this is resilient to all of these powerful binding adversary models. Like, yep, that's great. We already get that for free. Remove some stuff about how you can model the use of Diffie-Hellman in TLS 1.3 as a chem. That's not relevant to this document. We tighten up some language about the considerations of failure rates of MLChem. MLChem is like a lot of other lattice-based key agreement mechanisms, has a teeny tiny possibility that everyone does everything correctly and honestly and still does not agree on a shared secret. Like, this is cryptographically tiny possibility of failure rate. And we were talking about that explicitly in the document, but like the remediation for that event is just, try again. Just if you have a failure, just try to connect again. And so we removed a lot of that language because it doesn't help the implementer, it doesn't help the engineer reading to help them to know what to do. So we just cut that down very much to, you might fail by doing everything right, and just try again. Just tighten up a bunch of other language. And we were talking about, make sure if you're, because TLS 1.3 does not require you to generate the key agreement key pairs ephemerally. It is just, suggested that one should do this. You are not required. It's not a must. So there's language in there about like, yes, we recommend that you do this as well, especially for MLChem because it's very efficient to do so. But there was some language in there about making sure that the reuse bounds of your primitive can accept this. There are no reuse bounds for MLChem for any of the parameter sets, so we just basically cut that down a lot. Some other little wordage, some more stuff about fixed lengths. There was stuff about how these things are larger, like you can have 1.5 kilobytes for public keys and over 1 kilobyte for ciphertext, depending on the parameter sets you use. We just removed a bunch of that stuff because it's large, but not classic Michaelis large. So we don't have to make any accommodations in TLS 1.3 itself to handle it. And added acknowledgements. So that's out there. None of it is changing like specification or how the implementation or anything like that. It's just a lot of language and justification. Next slide. That's it.
Cool.
Questions?
Any other questions? All right, great. Thank you. Let me stop sharing those slides.
We have a Victor.
Oh, sorry.
Yeah, just one quick comment. OpenSSL, we did observe a very tiny number of servers that didn't like the larger client hello,
Okay.
and were timing out, and what's more, varied a lot depending on exactly the size by a few bytes, and you get in, and otherwise you don't. So
Okay.
there's a possibility that some connections will fail if you issue these key shares.
Was that for 1024, 768, or even 512?
That was for 768 hybrid, but mind you, the additional contribution from the EC is tiny, so it's close enough that certainly 1024 would be a problem.
Okay.
Chris?
Could we just ignore the possibility of decryption failure completely? I mean,
I
from a
don't
protocol
know.
engineering perspective, it just doesn't seem relevant.
I feel weird not saying because unlike ECDH, which is built in, there is basically no possibility of failure, even cryptographically teeny infinitesimal one, for everybody doing everything right for elliptic curve to be Hellman for any of the curves that we use in TLS.
But if the case we're worried about is like negligible on the order of like attack on, like breaking the actual like indistinguishability property, then I think it's fair to ignore personally.
All right, we're gonna go ahead and lock the queue.
Likewise.
Apparently this topic got like 10 people in the line.
Who's next?
Yeah,
someone pick Eric.
I'm +1 on ignoring it. There's like any number of reasons why you can get failures like this. As I put it out in the chat, like the TCP checksum is nowhere near good enough to exclude like random bit errors that cause Diffie-Hellman failure. So even if you're doing everything right, maybe you got TCP errors. So I think like we should just ignore this.
Yeah, Martin Thompson. Cullen Jennings once said, in the event of a hash collision, which at that time was much higher probability than this event, what you do is you crash the drive heads into the platter and burn the machine to the ground. We could specify that.
Okay.
Tom?
If we want to qualify what this decryption error does to the security of TLS, then we're looking at the correctness proof, and you're adding a factor that's smaller than 2 to the 128 to the like correctness error that you might get. So yeah, there is an effect on the security of TLS, but it's definitely negligible. I very much vote for not distracting everyone with this correctness error stuff, because I feel like it just pushes people into thinking that they're going to need to do error correcting and session recovery and connection recovery stuff that we do not need to do because it will not happen.
Okay. That helps me a lot, that like if you factor this into the correctness proof like bounds, it's like it falls out of the computation. So that helps assuage me a lot.
Just wanted to note we plan on implementing Peer 1024 in Chrome. We agree with recommended equals n.
Okay. Thanks,
Awesome.
Deirdre.
Thank you.
All right, Lawrence, here you are, and you get the clicker. And you get 15 minutes, so don't feel rushed. It's all right, no worries. I was overly generous.
Okay. Hello, Laura. I'm going to be talking again about the TLS 1.3 PAKE authentication draft. So just a brief recap of goals and motivation. TLS 1.3 has a mechanism for authentication using pre-shared keys. Those keys must be high entropy, and there's currently no mechanism to directly establish a TLS 1.3 connection when all the peers share is a low entropy secret. This could be useful in cases where connections must be authenticated with a user entered secret, such as like a PIN or a passcode. We're not aiming for general web login use case. This is mainly like to either bootstrap long-term authentication credentials or for just like a one-time connection. So the proposal is a TLS extension, PAKE, that can carry data necessary to execute a PAKE within the handshake. The PAKE registration phase will be application specific, so the draft does not cover that. And the choice of PAKE and required parameters for how to use it will be explicitly specified using IANA assigned values. Each PAKE is treated as a black box within the extension itself. As a first case, we've defined a concrete protocol for executing the SPAKE2+ PAKE protocol. Since Bangkok, we made two main changes to the draft. The first was we added a specification on how the PAKE extension can interact with certificate authentication. So this is useful in the case where if an attacker compromises the PIN, if there's no certificates involved, it could impersonate either the client or server. Again, in some cases, there might not be a concept of a certificate, but if one of the peers has one, it can provide some resistance to that attack. We also changed to combine the PAKE shared, like the PAKE-derived shared secret with the regular TLS key exchange mechanism. So instead of just using the PAKE-derived shared secret into the key schedule, it is now included, right now we have it concatenated with the ECDHE or concatenated shared secret from MLChem hybrid. The requirements for a PAKE to be used in this extension are it must provide forward secrecy and conform to the message flow of the extension. Currently, there are CPACE, SPAKE2+, and OPAKE all satisfy these requirements. And we have SPAKE2+ completely specified, and CPACE, we put a PR up yesterday for that one. So status and next steps. We have 2 implementations completed with support for SPAKE2+, including an open source implementation in Boring SSL, and we've tested compatibility. And we're hoping for an adoption call, which I think Sean mentioned earlier. Yeah. Sorry, I didn't look at the queue while I was talking. Yeah.
Becker? That's fine. Can you scroll back one?
Yes.
So I just want to flag that there's another requirement you haven't listed here, which we talked about on the list, which is that they must emit a fixed length output.
Okay.
Or must be made to be fixed length in some fashion, because otherwise you have to worry about injectivity on your queue schedule.
Yes, good point. We'll add that.
Dan?
Thanks, Dan Harkins. So I'm really in favor of this. Thank you for doing this. The IPsec did basically the same thing where they said, we're going to have this extension. You can plug in any PAKE you want. And as a result, nobody implemented it. It was really regrettable. I think it would be much better if instead of doing this extension and you can plug in a different PAKE, just do one, select a PAKE. And I think CPACE is a lot better than SPAKE2. The CFRG did a beauty contest evaluation and they picked CPACE. SPAKE2 was, I guess, a close second, but CPACE is much better. And I'm glad you have a PR up for it, but I would strongly advise you to just go with one, and CPACE should be the one.
Chris?
So I was curious how integration of 3-move PAKEs works concretely. So I think I read the draft back when I think SPAKE2 was the only thing there. And I think I understand how that integration works because it's just 2-move. But how do we do 3-move PAKEs like CPACE or OPAKE?
Samir, do you want to talk about CPACE?
I guess someone could describe how the PR works.
Yeah, so I think it's my understanding was that the output of CPACE is both parties derive ISK, right? And then there's a key confirmation step that's kind of like out of band, like the application needs to make sure that both parties agree on the key, and TLS gives this to you for free via the finish message, right? So we know that the handshake won't complete successfully unless both parties agree on ISK.
So it sounds like it's not like CPACE is like integrated into the protocol in kind of a black box manner. You're sort of like modifying it in a way that I think is like the like the right thing you would do, like just use TLS's key confirmation step. But just to clarify, this isn't like drop in CPACE. This is we're taking the main bit of CPACE and integrating it into the handshake.
Yes, and I would add that the same is true for the SPAKE2+ implementation. There's a confirm P and confirm V step that's like outlined in SPAKE2+, and because it's like a 2-move, because we want 2 moves, like we're also kind of, bending the rules a bit of like exactly the steps outlined in SPIC 2+.
So I would love to see, like, I really like this idea. I've wanted to see this for a long time. I'm concerned about trying to build a box around like too many moves. Like a two pace, like baking in a two pace is very natural, or baking in a three move pake is very natural. It makes me uncomfortable that we have to modify an existing protocol to jam it into TLS. So I think, like, to me, like, I would like to see what Fat thinks about this before we get too far, for example. But yeah, I mean, I think Dan has an answer here, which I think is worth considering, like, be opinion about the pig. I think at CFRG, we're going to hear about like a hybrid PQ thing, that we might be compatible with this. Maybe we just do that. And that's it. Thanks.
Watson?
So when I remember working on something a little similar with opaque, in opaque, you can get back the way opaque works is you have sort of a box on the server side and you turn the user supplied secret into the key that decrypts the box, and inside the box is a credential. Is the intention here to just use that as a client certificate for the rest of the handshake? Or is it that we have to do some intermediate step just to make it fit the pattern of the other pakes? And I think that difference might mean that you can't just plug it in. You have to do something different for opaque to really make it work out cleanly.
Yeah, I do think we need to probably look more concretely at how this would exactly work for opaque. It satisfies our like high level requirements, but you're right. There's probably some more looking we have to do.
Scott?
Scott Flores, Cisco Systems. Right now, as far as I understand your draft, you specify SPIC 2+ and to use the pre-configured N and M values that's in the draft. That brings up a weakness that where by solving a single discrete log problem, you can blow the attacker can actually just that destroys the pake properties. Either I would suggest moving to the per user N and M values as specified in that in RFC 9383, or if you feel strongly enough you can't, you need to mention that in the security considerations.
Yes, and thank you for bringing that up on the list. We can definitely add it to the security considerations and make sure we're okay with those properties.
Is there a specific reason why you don't use the per user N and M values that's already in the RFC?
I think, well, those would involve both peers needing to know them beforehand.
They need to know each one's identities, but I believe it should be the case already.
Okay, then maybe that's possible. I'm not super familiar with it. I'll have to look.
Thank you.
This is Richard Barnes, Cisco. So yeah, it's still very supportive of this draft, want it to happen. I feel like we're getting to the level of maturity in the discussion here where an adoption call is probably appropriate to the chairs. Responding to, I think it was Dan Harkin's comment, I don't think that nailing this to a single pake is the right idea. I think there's at least 3 options, all of which have stakeholders behind them on this slide. And so I think as is traditional in the IETF, we need crypto agility. We shouldn't nail this to one thing.
Yep. So again, we're going to do a working group adoption call. It's going to come out Thursday. I already sent it and it's queued, so it's good to go. Thank you for all of your input. And again, remember, we're adopting a draft. This is a starting point. Once we get hold of it, we can make it say whatever we want. So thanks.
Thank
you. All right, Yaroslav. All right, we're pretty close. I got the control. All righty, dual certs in TLS. And you have 27 of your 30 minutes. So, and you only asked for 20, so. All right, the slides are already up. I haven't read them. I didn't look at them at all. Yeah, 2 minutes. All right.
Hello again. So this is a work of 6 co-authors. So Hannes and I will do our best to represent a rounded view of all co-authors, but of course we have different motivations for this work and perhaps somewhat conflicting ideas, what's important, what's not. So I hope chairs will forgive if one of our co-authors will jump in and correct us or jump the queue to answer the question in a different fashion. So one of the reasons why we are bringing dual certificates proposal to TLS working group is because we believe that's an important topic to discuss. Today we're in, one could call, dark ages or medieval ages of PKI, where we use non-quantum safe digital signatures. RSA, CDSA, EDDSA. So once quantum computer is available that's large and perfect enough to break those digital signatures, then these algorithms will turn into a pumpkin. And we know what the future looks like. It's unicorns and rainbows, the perfect PQ digital signature algorithms that everyone will adopt. We don't get sure what they are. Maybe it will be MLDSA, maybe something else, we don't know, but it's distant future. Now, the question is, do we need anything in between? So can we just at some point flip the switch and go from what we have today into just pure PQ and don't do any transition whatsoever? Of course, the question is, when do we need to do that? We don't know when the big enough quantum computer will arrive. Maybe it's already here, we just don't know about it. Chances are pretty slim, but they're above 0, possibly. Then, of course, on top of that, there are somewhat conflicting regulations or recommendations from regulators out there. So, for example, there are certain regulations from NIST and NSA that say that pure PQ schemes are preferable. And then there is German BSI that says that certain technical guidelines, BSI TR 02102-1 says that it recommends the use of quantum safe signatures only in combination with a classic signature schemes. They do make an exception for SLH-DSA, I believe, but for ML-DSA, their recommendation is quite straightforward. They want a combination. So implementers or practitioners that operate in multiple jurisdictions or have multi-tenant systems that need to satisfy requirements of various customers, they potentially need some kind of flexibility to do both. And then, of course, one of the questions that was raised on the mailing list, when do we need to do it? Do we need to start talking about it now, or do we wait for some time? And of course, there is no one-size-fits-all answer here, because it takes different amount of time for different people. So some who just operates, who just subscribes or uses WebPKI can just wait until WebPKI gets adopted, whatever is adopted, and just update their certificates. Others who operate private or enterprise PKIs need to plan these things well in advance, and it might take years for some to roll out new PKIs, operationalize them, or outsource them, whatever people are doing. So in summary, what somewhat simplified view of the world, there are 2 potential approaches that we fundamentally can take. One is with composite PKI. Hannes, you want to cover that?
Yeah. So on the boxes on sort of starting on the left-hand side, so we have the traditional sort of PKI, or the box is supposed to indicate the additional traditional PKI deployment. And obviously you have, for certain types of deployments, you have a very long tail of products out there which will support that for a very long time. And that's what sort of is configured to the, or provisioned to the end entities. We also have on the right-hand side, we have sort of like already some initial attempts to deploy PQC-based solutions of a PKI environments. And then we had all these discussions in some other working groups on developing sort of the composite version of those, and where the the certificates are sort of integrated with each other, and we've also seen proposals in the TLS working group on how to get this to work. So that's the current state.
So the potential kind of downside, and we'll come to that, of this approach is of the previous approach is that you potentially need to have 3 separate identity certificates, classic, pure post-quantum, and composite, that would come from 3 separate PKI hierarchies, and that's suboptimal. So another approach that is that we're trying to describe here, with dual certificates, if you have just 2 PKIs, one traditional that we have today, and second would be pure PQ, perhaps MLDSA, perhaps mixed SLH-DSA with MLDSA, perhaps something else. And then if you want to serve a client or authenticate against a peer that would like to have both at the same time, you do combination on the TLS layer rather than trying to combine signatures inside a composite certificate. So I mean, the key upside here is that you only potentially deal with 2 identity certificates that are signed by 2 separate PKI hierarchies, and you don't need more than that.
And so what is said currently in the document is this approach, and there are, even among the authors, we did not agreement on, or there are different design approaches, and you can go either way. What we came up with is we have 2 separate lists of signature algorithms, here called first list and second list, which are then indicated by the client and selected by the server, which then have an impact on what is actually conveyed in a certificate message. The certificate message contains the chain for these 2 PKI hierarchies that we saw on the previous slide. And of course, then subsequently, the certificate verify message needs to include the signatures of both as well. So those are sort of clearly separated. Another design approach would be to concatenate the 2, which is done in some other related work, or to, instead of having, for the algorithms, the signature algorithms, instead of having 2 distinct lists, to actually come up with algorithm combinations that are probably most useful. So there's only one value and leads to fewer changes to the protocol itself. But that makes it very explicit on what's going on. So we picked that one.
Right. So in this session, we were not planning to go into the deep details on our current proposal. Rather, we were hoping that we would have a discussion about pros and cons of different approaches, and maybe come as a working group to rough consensus. Do we want this transition, or do we want just to flip the switch and we don't really care about people who don't trust MLDSA, so we want just to go from pure classic to pure PQ at some point, or we want to look into digital dual certificates, or we maybe want to do composites, or maybe we want to do multiple approaches since they potentially have different set of pros and cons. So the way we see pros of dual certificates compared to composites, that first of all, you have smoother transition to pure PQC mode. You don't need to create a separate pure PQC hierarchy. You could do traditional only, you could do PQC only, and then negotiate dual certificates for those who want to do dual certificates. And by the way, in our current proposal, of course, dual signature scheme does not replace traditional signature scheme. You can signal both at the same time. Then the most important thing for some of us is simpler PKI. PKIs are expensive. PKIs are risky. Running PKI is a complicated, in some areas it is audited, regulated matter. So reducing number of PKIs, running 2 instead of 3, for many organizations, that's already a significant win. And then, of course, in some multi-tenancy cases, there could be more than 3 PKI required for composites because people have strong opinions about what good composite looks like. Some want to do RSA with MLDSA. Some are okay with RSA 2K, while others want at least 3K because it goes above 120 bit of security, and that's a threshold that is drawn by some regulators. Some want to go RSA 4K. Others say that, no, we want the CDSA because RSA 4K signature operation is prohibitively expensive. And if you're operating a multi-tenant environment, that means that you need to spawn more and more and more and more PKIs. And then, of course, on the other side of equation, you might have different opinions about what good PQ looks like. And again, that creates potentially what I refer to as zoo of PKIs, which is not great from security perspective. And then simpler transition to new algorithms without the need to define a new composite. So again, today we have MLDSA and SLHDSA that are reasonably well defined. In the future, we might have something else. Maybe somebody will find vulnerability in MLDSA that reduces cryptographic strength. Somebody might come up with something better. Very likely that will happen in the future. In case of composite, we need to redo all potential combinations with each and every algorithm that comes up. With dual certificates, it's more straightforward. We already have somebody.
Yeah, so for just
well,
time
quite a
check,
few
we
people.
got about 15 minutes left, and there are 8 people in the queue. This slide apparently brought everybody out.
I blast through this one real quick. Already saw on the side the list building up. So obviously there are some disadvantage to the proposal as well. Name a few. Obviously the changes that we just showed on the other slide is non-trivial, I would say. We still have the management of 2 PKIs and PKI hierarchies. The message protocol size will get larger, and we also need to, also the security of the mechanism depends on the fact that you don't have, or the attacker doesn't have the ability to compromise the exchange in real time, so it can basically do a downgrade attack. Plus there's possibility to use some policies to, or distribute some policies to steer the selection of the different algorithms in different environments. Let's jump to the feedback.
Pascal.
Buzzman, Cloudflare. What I like about this approach is that it doesn't add the funny inseparability of composites or does the randomizer on top of that, and it's plain concat. That's all very good. What I don't like about this is that it adds a lot of complexity, which is a temporary thing. After we've done the transition, at some point, we will have this in it and we'll have to maintain it, and people will find use cases for it, which are useless. And another thing is that it's this increases the surface of where things need to be changed, right? A lot of applications interact and get a certificate from which is used in the connection, right? Now it's not just one certificate, it's 2 certificates. This will create a lot of issues. I think simple composites and no, just concat, that's, I think, the way to go.
You think just concatenation would be better for you? Or is that what you say?
Yes, just the composite signal. You install a non-PQ certificate chain, and you install a composite PQ certificate chain where it's just the simple concat, not the randomizer, not the separability, just the simple things next to each other.
Okay.
Andre?
Andrei Popov, Microsoft. I understand the desire to satisfy multiple conflicting requirements, right? Obviously, CNSA tells us pure, and they've published a profile that requires pure signatures, essentially, right? And BSI does prefer hybrids. I also know a lot of cryptographers at Microsoft who would like to see more composite signatures. The question that I have in my mind is, would this scheme with combining with the dual signing scheme, essentially with dual certificate chains, would that satisfy the BSI requirements? Because it's not the same as composite in terms of security, I believe, right? So what you're doing is you're making sure that 2 signatures are valid, right? But you're only doing it at the leaf certificate, right? So your entire certificate hierarchy is pure. still, right? So if there is a compromise of the algorithm, that is still an issue, I believe.
So obviously that will, if we decide to go forward with that, that will require very serious security analysis. TLS transcript certainly helps us in terms of reducing potential attacks. And then in terms of hierarchy, yes, you need to be super careful about not just the end entity certificate, but also the rest of the chain. And again, that's one of the reasons why the whole problem of having multiple PKI hierarchies arise. So that's why it's fundamentally different from moving to RSA to CDSA, because you could do that just on end entity certificate
Right.
and leave the rest of hierarchy as RSA 4K or whatever your favorite flavor is. Here, we end up with completely new PKI hierarchy potentially.
Thanks.
And to your question about like, is the BSI happy with this? We didn't ask yet. But, of course we could, but if this group says like, oh, go away, this is nonsense, then we better not ask, right?
Eric?
So it would probably be good to level set on why any of this is needed at all. Namely, so the naive thing to do, obviously, would simply be to have separate chains and not try to combine them in any way. And the reason why, as far as I understand it, and if someone wants to correct me, I'm happy to hear that. Why the desire to combine them at all is that you think that perhaps one of them is actually broken and you're unaware of it. Is that correct?
So it depends on how you want to, what your overall approach is to this whole migration. If you are of the opinion that you can sort of switch over from traditional to PQ, like then obviously this is definitely not needed. Nor is the composite.
Right. Yeah, no, agreed. I guess what I'm saying is that why not the answer to why not just say what I mean, so either if you trust, I think we could all agree, if you're willing to accept a pure traditional certificate, then like the PQ doesn't do anything, right? Because like the attacker will just stuff you. If the attacker has a cryptographic relevant quantum computer, they're just going to stuff the traditional version down your throat, right? So the only way in which you get security is by refusing to take the traditional certificate, right? And by insisting you have a post-quantum certificate. And then the reason, so why do you trust the traditional certificate at all? And the answer is for the opposite reason, that you're worried that maybe the post-quantum algorithm isn't good either, right?
Yep.
Okay. So I think like this is like seems like a very temporary state of affairs. So I guess I am also inclined to do the thing that that Boss, something like along the lines of Boss and Martin is suggesting, which is just like live with composites if we have to have this at all, and then assume the problem will shortly go away once everybody gets confident with like the post quantum signature algorithms. Like having to wear this kind of complexity forever seems difficult, and it seems like a number of the things you're sort of raising about the problems with composites really are problems if we thought we wanted to run this kind of thing in perpetuity. But I think we probably don't have to. So I think I'm undecided whether we need pure versus hybrid at all. But if we need hybrid, I think the answer is to divide new algorithms that are called like ECDSA plus MLDSA and pretend they were and just like with key establishment, just pretend that they were one algorithm.
Okay, makes sense.
All right, John. The queue is also like still 10 deep, so I'm going to apologize in advance because I'm pretty sure.
I was going to say what Ecker just said. It's this John Gray from Entrust. It's basically what composites is, right? It puts the two together. My comment was that the comment about needing 3 PKIs to do composite versus 2. I don't see that because we don't have crystal balls for the future. So I think there's an assumption here that at some point in the future, you're starting with your classic algorithm, you're going to do a composite in the middle, and then you're going to end up with a pure algorithm. But we don't know what's going to happen with that algorithm in the future. It could get broken. Maybe you're going to go to another composite combination of 2 PQ algorithms, right? Combining that 2 underlying hardness problems. So I don't think you can, we don't have crystal balls. We don't see the future. So I don't think saying that you have 3 PKIs is correct. Like you can set up one, like what Boss was saying, one RSA or traditional, and then you have your composite. Move to that.
And yeah, we believe that that's actually one of the benefits of dual certificates versus composites that have potentially more flexibility in terms of, yeah, you could absolutely do pure PQ, 2 pure PQ without having to define code points and the rest of it that's associated with composite certificates.
But then you have to change the protocol as you're suggesting, which with composites just drop in.
Well, based on what Barnes and Ecker suggested, you in that case, you wouldn't have to change the protocol because if I understood their proposal correctly, it would be assign a code point for the combination. So the negotiation would like be the same. And for the certificate, it would just be the concatenation. And so from the look and feel would be like, oh, there's some certificates in there. And then for the signature, it would just be, oh, the two signatures sort of concatenated together. It wouldn't be like what I just presented previously with the strawman proposal.
That's, in my mind, that's basically composite.
No, it's not.
It's one signature, one order. It's just an algorithm.
No,
well,
algorithm. No, it's not.
Anyway, we can argue about
okay,
that on the list or
happy
afterwards.
Martin?
Yeah, just briefly, I think the changes to the TLS part is something I'd like to avoid. Having an identifier for the signature algorithm that's actually a composite and so forth simplifies the TLS half of this problem considerably. I'm coming around to the idea of having multiple certificate chains because it gives you the flexibility of being able to decide whether you want one or other or both. And I think the point at which that goes from being concatenated is the signature algorithm. The signature itself. The signature is a concatenation of two signatures, but in the process of validating that, you would then look for two different certificates and two different certificate chains at that point. And all the chain building stuff wouldn't necessarily have to change in the stacks. You just skip the certificates that don't apply to that particular chain that you're following back up again. It's just you'd have to do it twice. The problem, of course, is that with all the redundant information in multiple certificates, you end up with reduced efficiency and whatnot. But given that the size of keys dominates here, I don't think that's a major consideration.
Watson.
Thanks, Martin.
Hello, Watson Lad, Akamai. I don't think that adding complexity to TLS layer is desirable because we'll have to live for it a long time. I think some of the rationale in terms of, well, it's expensive to run multiple routes isn't really looking at the cost the right way. Because when you have a PKI, some of the interaction cost is just authenticating that, yes, you get the certificate with this information. That can be spread out across multiple different certificates going to different places. And also, you don't necessarily need, if we go and define a signature scheme that is a composite of a hash-based and a post-quantum, if we define a signature scheme as a composite of a post-quantum and a classical scheme, you can use that as the identity certificate and then go and through cross-signing and various chain mechanisms, have the classical supporting things go chain up one way and have the post-quantum ones chain up another way with the pure signature. That's another option to avoid having to, if you don't want to run three routes. So already existing X509 and TLS capabilities exist to solve this problem. And I think it's a lot, we've already built libraries to support adding a new signature scheme very easily. We've already built applications to negotiate that. It's a lot simpler than putting in a TLS extension. You're going to get where you need to go a lot faster.
Mike.
Hi, Michael, UK NCSC. For what it's worth, I think we're happy with PQC only, so a lot of these discussions aren't needed. However, if the working group decides that hybrid signatures is the way to go, whenever you decide to do that, then I like this proposal exactly for the reason that's on screen, that smoother transition and the flexibility is nice. So thank you.
Jonathan?
Hi, Jonathan Hoyland-Klaffler. So I was wondering, does using exported authenticators to simulate this give you the same guarantees? So specifically, if you do classical classical handshake and then send a PQ exported authenticator, does that give you the same guarantee as doing this compound, doing this concatenated signature?
Jonathan, that was our very first design with exported authenticators. Unfortunately, the changes were even more severe to the whole TLS handshake. So that's why we kind of backtracked to the current proposal. Oh, and by the way, this proposal also actually works quite nicely with exported authenticators. You can use the very same approach to do 2 certificates inside exported authenticator. We can take it offline if you would like to dive deeper into that. Thanks.
Thank you.
No, I mean, we're nearly over time, but I would like these people to, I'd like to drain the queue here because there's some people that have some press buttons to get things in code bases. So.
Dennis Jackson, Mozilla. I really think that like if we're going to do hybrid signatures, then composites would be the way to go, to have a single signature algorithm, which is the combination, and then sort of avoid the need to do all of this at the TLS layer. I really think like a lot of clients are going to struggle with the idea of hitting a callback that's going to return multiple certificates or one of the two. The idea of keeping them both in sync, like so you're checking that the SAN is correct for both of them in some context where you're reusing connections. I think there's just a lot of like untamed complexity at that level that using a single kind of composite certificate would avoid. I do also think that like, you know, we've become a lot better at rolling PKIs. And I think like the situation there of like 2 or 3 is maybe not such a big deal because whatever the cost is of one, it actually makes the cost of the second transition, I think, probably actually cheaper rather than anything else. But yeah, thank you.
Tom?
I briefly looked at the draft and I saw that you put quite a lot of words into this already, which was good to see. But I still want to highlight that I feel that this design encourages the reuse of existing PKIs in a sort of hybrid or composite setting, which then you might have less complexity in the PKI management side, but then you have to very carefully define for which applications, which keys are trusted, when they need to also enforce that they need to see a DSA key, when they don't need to do that. Whereas if you just mint a new PKI with composite roots, fresh keys, even if you use Watson's idea where you mint a new leaf key, but then chain that up 2 ways, I feel like that's less complexity than if you end up reusing the existing leaf certificate plus a new one in a thing, because I feel like, yeah, just the potential for all sorts of weird downgrade attacks is huge, and getting that exactly right in your policy sounds very complex to me.
Yeah, it's thanks, Tom. I don't think it's a solution for all the different PKI deployments. That's for sure. Like some deployments may not even have worried too much about like the transition because they are issuing very short certificate life or certificates with a very short lifetime and have a very good possibility to rotate things. Maybe are very flexible in terms of what the devices support. But for others, that is an issue.
All right, Victor? Or sorry, Stavros.
Yeah, thank you. So Stavros Kouzias from the BSI. My gut feeling with that solution is that you're trying to solve one problem and you are creating 2 new ones. So I think it's just summarizing what people already said, is that you are pushing the problem of doing something that is hybrid to the application. So taking it away from the crypto low-level problem and saying every application has to solve this now. It's TLS and every other application that uses X549 certificates or certificates at all. And the second problem is that you introduce much more complexity in the certificate management. So users are not able to manage one certificate. Now with PQC, they will have 2 at the subscriber level, and with that approach, they will have 3. The This is only my gut feeling here.
So thanks for the feedback. When it comes to the first one, well, we have already very TLS specific hybrid key exchange that is not applicable to most other protocols, and there is X-Wing for more generic things, but your points are valid.
Yeah, and one thing is that reminds me of history. So we had similar discussions 3 years ago when we started with introducing post-quantum into protocols. And I remember many people at IETF that were very reluctant about that modular approach and opting for the composites. So, okay, thank you.
Victor?
Sure. So while this isn't nearly as bad as X9.162 with their second key inside the same certificate and massive complexity, I still think composite is the way to go here. For example, how does one do SNI here? That involves typically application interaction of dynamically retrieving the appropriate chain for a particular SNI name, and now the application will have to be modified to retrieve two chains. How does one log the what the key agreement was? Applications expect to be able to say, we used a particular key agreement, but now there are two underlying ones. So this bleeds into too many areas for me to be comfortable that this needs to happen. Yeah. So very skeptical. Composites seem simpler.
Okay, so that's the end of the queue. I think what we're going to do is take this to the list. I want to thank you two for taking this. I want to thank everyone for keeping the conversation nice, and we'll see you all tomorrow. Thank you.
You asked the data supplement because I have to do a conference call.
Okay.
That was actually not all of this. I was not. Yeah, so maybe not sure.